Good morning, everyone. My name is Tanushree. I'm presenting this project together with my teammate Arika from Executive Ongoing. We are doing our internship in Emertex Institute. Our project title is Home Automation. In this project, we used Ar- Arduino and Internet of Things technology to make simple home devices controlled remotely and to add basic automation features that save energy and increase convenience. Coming to things we learned during the internship. During the internship, we learned the fundamentals of C programming include conditional statements, loops, operators, arrays, and pointers. We also practice writing and using functions, handling strings, and understanding storage classes. In addition to software concept, we learn about embedded system and basis of Internet of Things. We use tools such as Arduino, IDE, PiximLab, and a IoT platform. All these skills we import for designing and implementing our home automation system. Coming to agenda, today I will first give you a brief introduction to home automation and IoT. Next, I will explain the functions overview of system so you understand how data flow from the scenarios to action. Then I will show the block diagram that map the hardware connections. After that, I will describe each component used in this project and explain their roles. I will I will briefly explain the concept, then the main advantages of system and finally discuss the possible features improve and scope. Introduction to IoT and smart homes. The Internet of the Things or IoT refers to connecting everyday devices to the internet so they can exchange information and act intelligently. In the smart homes, devices such as lights, fans, cameras, and can be remotely monitored and controlled through a mobile phone. IoT systems make home more compatible by allowing automatic adjustments. For the example, lights turning off when your room is empty. The air conditioner changing temperature based on the user preference. IoT also improve safety and energy efficiency by enabling alerts and automate energy saving actions. Coming to function overview, how the system works. First, small devices such as lamps, fans, and are installed in the home and connect to the control. Second, these devices communicate with the center hub or microcontroller, which in your case is Arduino UNO. That scenario, select the environmental data like temperature and light level and send this data to Arduino. Fourth, Arduino process the data and decide action based on the predefined rules. For example, it can switch on the fan when the temperature crosses the threshold. Fifth, user can control devices remotely using mobile application or send command from the web interface. Finally, the system can perform automatic actions and send alert when it detects unusual events such as open door or smoke detection. Coming to block diagram explanation, this block diagram shows the relation between the main parts of our project. The Arduino UNO is the central controller that reads the input from the scenario and drives output to the actors. The LDR and LM35 scenario are connected to analog pins of the Arduino to provide real-time life density and temperature reading. As Ethernet shield attached to the Arduino provide network connectivity so the system can be controlled remotely through the internet. The LED module displays the current scenario, reading and device status locally. The output devices such as lamps, fans are connected to the Arduino output pins through operator driver circuits or relays. The next topic will continue with my teammate Arika.
Hello all. Now I am discussing about the components required and their roles. The first main component is the Arduino Uno, which acts as the system's brain and run the control the program. And the second one is the Ethernet shield. Ethernet shield is used to connect the Arduino to a local network or the internet. So the remote commands can be received and status can be sent to the user. And the next we use LM35 sensor. It is the temperature sensor. It measures the ambient temperature and provides an analog voltage proportional to the temperature in degrees Celsius. And then we use LER sensor. LER sensor measures the light intensity by changing its resistance according to the ambient light. We use it to decide whether the switch is light light whether the switch light is on or off automatically. And then we are using the LCD display. In this LCD module display, it is very useful information. It will give useful information such as temperature values, light level and device status, so users can see system's readings at a glance. Each component has a clear role and together they form working automation. And now present I will present you the demo of the project, so that we will go to the demo session. First we have to click the Pixim Lab. When we click Pixim Lab, it opens like this. And now go to the file, click on the load hex. It will take time. um, present I'm connecting present I'm save the file name as the home automation blink control. Click on the home automation blink control and the click on the home automation blink control load hex file and load it, so that we can see the output. When we go to the modules, wait mm, when we go to the modules, there are spare parts. When we click on the spare parts, we will open it will open a window like this. Here we can see that this is the LDR. When we reduce the resistance, the light will glow. You can see that. When we increase it, it will automatically off. In home automation, we used it like a gardening lights. So in night, it will glow. After sunlight is arrived, it will off. After that, we will control an AC, that means air conditioner, and we will control the water tank. Let's see how AC will work. To work to see that, we are using an app, an IoT integration app, which is called Blink IoT. We are using this. Here I am clicking on the switches. It is a cooler and it is a heater. It is a temperature level. Here we can see the temperature on the 27.3 When the heater is on, it will gradually increase the temperature. It will take time. Let's see. I am turning off. Now again I will turn on this. Um, let's load again. I think it doesn't load correctly. Open. Go to the spare parts. Here it displays the home automation. And then Let's turn on the, okay, the net is fluctuating. Uh, Here this is the proof of the concept. Now we will see the advantages of this system. This home automation approaches provide several important advantages. First, it proves convenience because users can control lights and appliances from their phone or by scheduling actions. Second, it saves energy because devices are turned off automatically when not needed, which can reduce electricity bills. Third, it enhances security since sensors and network connectivity allow the system to send alerts be monitored remotely. Fourth, it it increases the comfort because environmental conditions such as temperature and lightning can be adjusted automatically based on your preferences or sensor readings. Overall, the system brings a small but practical improvements in everyday life. Um, in the future scope, there are several ways to extend and improve this project in the future. We can add voice control and AI features to allow the natural language commands and predictive automation based on their user habits. We can implement smarter energy management algorithms that learn usage patterns to further reduce power consumption. For security, we can integrate advanced sensors and face recognition to identify authorized persons and raise alerts for unusual activity. We can also connect the systems to the larger smart city frameworks so homes can coordinate with public utilities for optimized energy and resource usage. Each of these upgrades will make the system more robust, user friendly, and efficient. Thank you for listening our presentation on home automation. We hope this demonstration gave you a clear idea of how Arduino and IoT can be used to make home smarter, safer, and more energy efficient. We are happy to answer any questions you have. Thank you.